Have you ever wondered how an aircraft wing generates a lift?
Lift is so complicated that we have quotes like these. In contrast to turbulent flow, where air molecules move in all directions, we consider airflow over the wing to be laminar, where air molecules move in layers like sheets of paper, but do not move between layers.
Let's first use the ground as the reference frame and look at a cross-section of the wing. The wing is usually positioned at an angle called the angle of attack. As the wing moves through the air, the leading edge and the bottom surface push the air molecules closer together. Along the top surface, the wing is creating space for the air molecules to expand. This manifests as a pressure gradient. From wind tunnel experiments, we find that the highest pressure is just below the leading edge, and the lowest pressure is just above the leading edge. The streamlines above the leading edge deflect slightly up and accelerate due to the low pressure on the top surface. Past the leading edge, the lower pressure along the top surface also accelerates the streamlines and deflects them downwards. Some of the streamlines slightly below the leading edge actually get deflected up over the leading edge, accelerate, and deflect downwards over the top surface. Streamlines well below the leading edge also get deflected up but don't make it above the leading edge. They encounter the high pressure zone, slow down, and deflect down along the lower surface. Effectively, streamlines above and below the leading edge deflect down. Lift is the upward force experienced in reaction to the downward change of momentum of the air. Now that we understand how lift is generated, it's interesting that there's no easy way to model and calculate lift. The Navier-Stokes equations do a good job of predicting lift, taking into account conservation of mass, energy, momentum, viscosity, and other parameters. Even with supercomputers, solving these equations in 3 dimensions becomes extremely difficult. So engineers have come up with a simple way called the lift equation to calculate lift. Coefficient of lift is calculated experimentally in wind tunnels for specific wing geometries and angles of attack. Rho is the air density, v is the velocity, and a is the wing area. An Airbus A380 can generate 20 tons of lift for every ton of thrust, compared to a rocket which only produces 1 ton of lift for every ton of thrust. Isn't that cool?